Okay, question 11. Given quadrilateral ABCD has vertices at A, x1, y1, B, x sub 2, y sub 2, C, x sub 3, y sub 3, and D, x sub 4, y sub 4, prove that quadrilateral ABCD is a parallelogram. Which statements about the coordinate proof for this problem are true? There is more than one correct answer choice. Select all correct answer choices. So if you had not watched question 10, then this is the explanation that I had given them in that one. I went to the coordinate proof section and I had selected the show all. So this is the step 3, step 4, and I had listed to prove parallelograms. I just listed all of the reasons right here in my notes, and so that I could use this as a reference to know how to prove parallelograms. Now, x sub 1, y sub 1, they're just generic representations saying a number would go here for the x coordinate and a number would go here for the y coordinate. The x sub 2, y sub 2 represents the same thing. Another number goes here for the x coordinate, another number goes here for the y coordinate. Same for the x sub 3, y sub 3. It's just showing that this would represent a number and this would represent a number. So I would just scan through this and make sure that I understand what's going on. We had the definition of a diagonal. They used the midpoint formula to find the midpoint for the diagonals. So I could include that to find midpoint for diagonals. And then they used that if two lines intersect, then the intersection is at one point. This is meaning, this is how I interpreted it. I interpreted it that the midpoint for both segments is the same point if it has the same coordinates. Okay, so then they had the definition of a midpoint, definition of bisect, and then they said diagonals bisect each other, then it is a parallelogram. So just scanning that, now I'm going to go through these and see if I can select select them. So to prove that the diagonals bisect another diagonal, you must show that the two diagonals have the same length. Well, this does not talk about distance of the diagonals, it's been talking about the midpoint, so I'm going to move on. To prove that diagonals bisect another diagonal, you must show that one diagonal passes through the midpoint of another diagonal. Yes, this is saying that if two lines intersect, then the intersection is in one point, so that's saying that one diagonal has to pass through or intersect the midpoint of the other diagonal. So that is where that one is being represented, is by the reason 3. So to prove that both diagonals bisect each other, it's necessary to show that the midpoint of one diagonal is the same as the midpoint of the other diagonal. Yes, to prove that both diagonals bisect each other, it's necessary to show that the midpoint of one diagonal divides it into segments that are congruent to the segments of the other divided diagonal. I'm saying no because this did not talk about to show that the midpoint of one diagonal divides it into segments that are congruent to the segments of the other divided diagonal. It's not talking about congruent segments to the other diagonal. It's talking about the segments on each diagonal. So like in the quadrilateral, it's comparing if we had this right here, it's comparing these two segments to each other, not to this segment to this segment. So that's not true.